What'd you say? No idea, but Mr. Cat said so. So if you believe in Mr. Cat, then
I I believe in the power of Mr. Cat.
all right.
Miss Coleman and Miss Rogers also said it's gonna be a snow day.
I don't know. All I know is I don't need to plan for e-learning for tomorrow if we have a snow day. Because they figured out we have 4 days. They were thinking that we only had 1 or 2 left, but we actually have 4 days left. So like, okay, we can go one more snow day without panicking. Who knows? They didn't ask a math person to count, right? They should have asked me. What?
The 249 counted that we had that many snow days, or
No, we counted and admin was starting to say, hey, we're gonna be in trouble if we don't start e-learning. So they were planning last week, they were like, hey, looking like snow next week, so we should plan for an e-learning day, that way we don't get in trouble. And people were like, well, how many snow days do we have left? And they're like, we're almost out. And then they finally said and did the math, they were like, well, wait, we got 4 days left. So they're not gonna wait till we get to 0. That ain't gonna happen. So like, okay, we can get down to 3 days before we need to work on it. So I'll just say, this is gonna be our last free snow day, if we have one more, if we have one. So we're not gonna, we got 3 snow days left and then not make any plan, because you could have 3 snow days in a row and then we were in trouble. So the very next snow day, if tomorrow's a snow day, we have one more nice, easy, nothing to do for snow day, and then we're gonna start e-learning. We're not getting impacted. No. Okay. Make sure your homework's turned in. We've arrived at the last section. All right. You want today to be easy or hard? It is an easy day. All right. All right. Homework tonight. You got it. She said, if it's snow days tomorrow, will the test get pushed back? And I went, yep, you will. You don't want that to happen, though. You want to know why? That means we're going to be reviewing on a Thursday, and the test is on Tuesday. You would much rather do a review and then take the test the next day.
But if it's that, if it is that, can you just give us 2 practice?
No.
But it gives us a whole weekend to make it great.
Yeah, it sounds so good on paper, right? The kids will definitely study if I give them 4 days.
Mr. Shardy, can you record the class if there is a snow day tomorrow? Because I won't be here Thursday.
Well, I'm not going to be here if it's a snow day.
No, if on Thursday, if we have a snow day tomorrow.
Oh, I can certainly record the audio, but remember when we do a review day, I just show you and then I write on the board so you won't see anything. But if you want to record, I can do that. I don't have access to it.
Oh, what? But it's in your classroom.
Yeah, I don't have access to it. What does she do?
She just writes on the board and has her computer as a camera to record. So you could like, since normally you
Yeah.
just have like the.
Yeah, I could do that. I could do that. All right. All right. So we promised it was an easy day. These are not going to be easy proofs. All right. Area of triangles. Hey, area of triangle.
What do you want?
Area of a triangle?
Something squared.
Oh God, no. Come on, 5th grade, area of a triangle.
Oh.
Say again? Oh no, that's area of a prism. And a rectangular prism.
All of the sides,
No one can tell me area of a triangle?
all of the sides multiplied.
He said HB over 2. What in the world does that even mean, HB over 2?
Height times base over 2.
Is that the right formula?
Yeah.
That's the formula, right? Hey, one person already knows this, right? And he said we're supposed to take, given triangle A, B, and C, right? We're supposed to take the base. Which one's the base? Every math teacher doesn't have a math degree always says the base is the bottom. But the base is any side. Yes, typically we choose the bottom. Hey, what's opposite capital B? Little b. And I'm telling you, this is why people think it's always the bottom. Because they'll draw the triangle like this, and they'll say, oh, the bottom is the base. It makes sense, base being the bottom. But really, it's any one of the 3 sides could be the base. And what are we supposed to do? What's the height? Where's H?
Is it H is equal to the sign thing that you?
We're in fifth grade. We're not in pre-calc yet, no.
The middle
Right.
of the triangle,
It's not necessarily the middle of the triangle, no.
the highest point of
Little
the
b
triangle.
to big.
Say again? From little b to big B? Okay, that's a good fifth grade answer, right? How do you want me to draw that line?
This way.
Dotted.
How else? How else?
And down.
There's a million lines that go from the base to B. There's a million red dotted lines that go from the base to B. How do you want me to draw it?
This way,
Cool, from.
You
big
need
B
some-
all the
You
way
need some
down.
words.
Up, down.
We need some math words. We don't have up, down.
90.
90 degrees, thank you, right? So we need it to be a 90 perpendicular line from the base to the opposite vertice. That's what you were told.
Not fifth
Fifth
grade.
graders don't know what a perpendicular line is.
Yes, they do.
Or what a base.
They have to show them the little square and they'll say 90 degrees. You learn your degrees in fifth grade, right? And so that is your H, except we call it not H, we call it fifth grade.
Triangle too.
It's called H for a reason because they don't say H, they say height, right? That's why it's literally called H, by the way. And therefore they get that formula right there, which was from fifth grade. Well, that's great if you know the and the, what if you don't know that? Well, then you can't calculate the area in fifth grade. Are you in fifth grade?
No.
So guess what's gonna happen tonight? You ain't gonna know the base and you ain't gonna know the heights. So what do? That's what today's class is on.
Well,
Right.
if you said it could be any side and they give us one side, can we just use that one side?
That is a possibility, but you still need a base and the height. Tonight for homework, you ain't gonna know the base and the heights. Okay? So the but here is that, well, our book, it doesn't show you the fifth grade formula. Guess why? Hint, hint, hint. Guess why? Guess why?
Because of the side,
Guess why?
because the side's no.
The formula says A is equal to 1/2 base time height, but our triangle is named,
ABC.
well, A is the area, not the angle. So our book, instead of having the fifth grade formula, just choose a different letter.
D.
Okay, they chose K. Do you see that these two letters are exactly the same?
Yeah, okay.
This is an angle, that means area. Area is not an angle.
But why K? Why not?
Oh, I have no idea, right? They chose the letter K. So they start off this lesson with, hey, reminder, the formula for area of a triangle is K is equal to 1/2 base times height. So the normal person says, why are they using a K? Did I just explain to you? You understand why they're using K? Could they have used a D? They could have, right? All right, cool. But once again, you're not in fifth grade, right? By the way, nobody uses that formula, everybody uses this one, right? Like when you grab your calculator, nobody does 0.5 times base times height, right? Everybody does base times height divided by 2. Is that a correct assumption?
Yeah.
Okay. All right, yay. But today's class is what if you don't have the base and the heights? So we're going to get 2 new formulas to cover all possibilities is what happens if I don't have a base and a height, right? So why do we need the new formulas? Because I ain't going to tell you the base and the height now. I might tell you one of those, but I'm not going to tell you both of those. What if I have a new triangle and all I have is that? Now imagine these being numbers, not letters. So what did I just give you? I gave you 2 bases, but I did not give you the height. So in order to find the area of that triangle, we need a new formula.
Why not just use the past one?
The one
Well,
that
I need the height. I don't have the height.
Yeah.
well, what about the one that says H is equal to the A
Oh, so
side?
maybe that's where our formula comes from.
Why can't we just use the same formula if we're doing the same thing?
Yeah. What's the height of this triangle?
I don't know.
Exactly. So I
No,
can't
we don't
use
know
this
right
formula.
now. No, we're not talking about that formula. We're talking about the past formula that we already learned to find out what.
Your
H
past
is.
formula is base times height divided by 2.
Okay.
No, the one that
Are you
says H
serious?
is equal to,
Agreed. I said today was not a hard formula. right? I'm just pointing out the fact that I'm not gonna give you H, so I can't use this formula, right? H is there, I simply need to calculate what H is. Okay, we can do that. Hold that thought for a second. So there's scenario number one. They're gonna give you two sides and the angle in between. Okay? There's another option they could have, right? Instead of two sides and the area in between, maybe they don't give you any of the angles. Maybe they give you, instead of this, right? Now this is called SAS, you can see why, right? Maybe instead of this one, they give you this one. Well, what are they giving you? They're giving you SSS. And supposedly you can calculate the area of this triangle with an SSS. Well, can you use this formula? I don't know what the height is. I know all the sides now, but I don't know a single H. So therefore I can't use that formula. So you're going to get two new formulas, one for the case of SAS and one for the case of SSS. Both formulas are different from each other. They look very different from each other. I'll just say the SSS one looks really panicky. It's the hardest proof, one of the hardest proofs of the year, but to actually do it, it ain't that bad. So don't panic on the SSS one, right? We're going to get a new formula for SAS. We're going to get a new formula for SSS. So we're going to start off with the easy one, the one that you already figured out. Okay, what am I missing in that formula in order to use this one? I'm missing H. So it's a pretty simple proof and you've already kind of figured it out. Well, let's draw the H. It's right there. Okay, I need to figure out what H is for this formula. So how are we going to figure out what H is? I'm given everything in black. Like those are actual numbers and values. I'm given what's in black. I don't have what's in red. I need what's in red in order to use this formula. So what do? So how do I find H? You already told me this, YouTube. What did you say before?
Go to side, sign, yeah.
B times
Yeah.
sine A.
No, but what with these right here?
Sign C.
You said B though.
A.
A times sine
H
C.
is equal
A
to
times sine C would equal to H, right? So I can get that using this. Sine of C is opposite, which will be the H over the hypotenuse, which is A. So now I can solve for H using multiply both sides by A. So therefore I can take this and substitute it for the H, and boom, there's my formula. It looks remarkably like the previous one, it just doesn't have H. So here's my new formula. This is the old fifth grade formula. Except fifth graders don't know what sine is, right? So they can't use this formula. Okay. So that's our new formula. Okay, let's write this. This is called the SAS area formula. Write this down. The triangle has to look like this. You must have SAS. But if you have SAS, well, we can use the old fifth grade formula, base times height divided by 2. It's just that H is equal to this trig thing, B sine C. And yes, most people on their calculator are going to use this other one to the right of it. Most people are going to do AB sine C over 2. I did not say today is a challenging class. It's not. So what's the pattern? The pattern, if you have SAS, is you take these two numbers and you
multiply by sign.
then divide by 2 and then multiply by sine C. That's the pattern. Sometimes you can do parts of it in your head. Other times, if the numbers aren't friendly, well, then you grab your calculator, right? Could you do AB sine C divided by 2? You can, but remember, A and B are just going to be numbers. Multiply and divide by 2, and then multiply by sine C. Hey, I just gave you all the stuff on the left side of the triangle. What if it's on the right?
The same thing, just opposite.
It's going to be the same thing, just with different letters, right? So guess how many of these in yellow we're actually going to get?
15,
5,
6.
10.
Seth is showing 3 fingers.
Okay.
Yeah.
Why 3?
And there's 3 sides.
Because there's 3 sides or 3 angles, right? So the question to you is, if I have the complete triangle, do you need to write all 3 down? But you do need to know the pattern. So for instance, if it was the top, what's the pattern? If it's just the top, what's the pattern?
AC
Divided by 2 times,
sine B.
that's the pattern.
Wait, could you multiply AB sine B? Well, AB sine C and then divide it all by 2?
Of course.
I have to.
Well, I'm just saying, like, A and B are gonna be numbers. I'll show you my example. If A is 2 and B is 3, 2 times 3 is 6, 6 divided by 2 is 3. I mean, I'm saying sometimes you can do that division and a little bit easier. All right, so are you writing all 3 down, or are you just writing that 1 down? So I can go on? Everybody happy? Okay. All right, so you do have the pattern though for SAS. All right, so here's your example. Hey, is this one SAS? Okay, so what are we supposed to do? 6 times 8 is 48. Divided by 2 is 24. Sine of 30 is a half. Half of 24 is 12. I just did that whole thing in my head because I knew what the sine of 30 is. Well, that was convenient. But what if it had been 31? Then I have to have my calculator. Multiply by sine of 30 is a half. Because sine is y and y at 30 degrees. Now, no, I wasn't trying to impress you to do the whole thing in your head. I'm just saying that the math is pretty darn straightforward. Hey, why don't you just type the whole darn thing in your calculator and just be done with it? Yes? Now remember, we are calculating area, so it's just not 12. It will be 12 square feet, 12 square inches, 12 square meters, 12 square units if there's no units. So we got problems or no? Okay, look at your screen. Don't look at the board. Look at your screen and read what your screen says. Don't look at the board. Read what your screen says.
8 sine 30.
Okay, it must be in radians then. Aha! What was the answer it was giving you? Yeah, so this is one of those ones where, hey, that sounds like a reasonable answer, 23.6.
Okay, I got it.
Yeah, but I'm saying, like, you will never, unless you get like a negative number, and you're like, well, the answer can't be negative, you would not have caught that on a test, right? Hopefully there was another question where you had gotten a weird answer, and you were like, oh, I'm in radians, and then you got to go back and fix things. But I'm just saying, don't ever take a quiz or a test without checking your calculator first, make sure it's in the right form. All right, yes? What if instead of giving the picture, right, they gave you that? Okay, just draw a generic triangle.
C in the.
Okay. So what is always opposite the angle? Little c. And notice they didn't give me little c, they gave me A and B. It doesn't matter where you put A and B, right? So that's my 3 and that's my 4. Hey, this time they gave me sine 50. I can't do sine 50 in my head. I got to use a calculator. Times 6. Because half of 12 is 6. I got 4.6. Is that what you guys got?
Yes.
How many word problems are there?
1, I think.
Just one on the test?
Oh, on the test, yeah.
Just one on the test?
Yeah.
Okay. Maybe I'll get a perfect paper this time. Maybe.
Seth says give you 4 word problems.
That can
I
take
will
those 4
literally
word problems himself.
Well, you almost got to the answer. The other one, you weren't that far away. All right, we good on this one because I only had 2 examples. Okay, so pretty slick and nice, easy formula. The pattern's pretty easy. Just remember, it's a lot of stuff this chapter. But when we take the practice test, just don't show up without a resource card or 2 or 3, right? 2 resource cards, whatever you want written on them, unit, circle, and your trig identities, right? Yeah, well, there's plenty of stuff in this chapter we've used the unit circle. Yeah. Well, I just used it. To do that one sine 61 or sine 30. All right. SSS is the ugly stepchild, right? That's an army thing. That's kind of offensive. I shouldn't say it. I don't know. They say that in the army, and it's always a redheaded.
What?
If you join the army and you're the outcast, you're always called the redheaded stepchild. Yeah. So that is a little offensive. All right. Okay. Okay, so the SSS, the actual formula, do not panic. It's a panicky looking formula, right? And you will panic. But when you actually do an example, then all of a sudden, like, okay, this is pretty simple. Not as simple as the previous one. SAS is really simple. This one is, it's got some stuff to it, but trust me when I say it ain't that bad. Okay, some of you are going to immediately panic because of this proof. Okay, so it is a challenging proof, right? I want you to remember this one. This is the SAS formula, right? Okay. So how do you calculate the area if all you're given are three sides? All right. This is if not the hardest, one of the hardest proofs of the year, right? Very simple outcome, right? For those of you that get panicky, there's a pig with a flower. All right. Okay. All right. I'm going to start off with a triangle. Triangle ABC with side lengths A, B, and C. So I'm given, because it's SSS, I'm given those three sides. Okay. I'm going to reach back to my tool and I'm going to pull out the law of cosines. So I pull out the law of cosines. I can solve for either A, B, or C. I'm going to solve for C. So there's the law of cosines for C. Yes? All right. Yesterday's homework? Okay, cool. I'm just going to move things around. I'm going to move the minus 2AB cosine C to the left side. And I'm going to move the C squared to the right side. All I did was just move two things. Yes? Okay. And then I'm going to get cosine C by itself algebraically. Yes? And then I'm going to pump the brakes, and I'm going to say, ignore all that for a second. We'll come back to it in a second. Okay? From out of nowhere, I'm going to yank over here the half angle formula for cosine. Why cosine? You'll see why, right? But these two ideas right here do not at all join together, seemingly. Like, why did you choose that? Well, somebody smarter than me chose that, not me. I would not have known to choose that. But they said, hey, think about the half angle formula for cosine. Anybody like square roots? I don't. And it's a plus or minus. Rather than figure out whether it's plus or minus, why don't we just square both sides? So if I square both sides, I don't give you square a positive, you square a negative. The square root goes y and it's positive. Yes? See what it did? Okay. Now, here is why we went down this half angle formula. Because this says, and so does this. So I can do a substitution. So that says cosine C, this says cosine C. So I'm going to take this piece right here, the a squared plus b squared minus c squared over 2ab, and substitute it in for this half angle formula where it says cosine C. Big, hot mess, right? All I'm doing is a substitution. Yes? Okay, now I'm doing a little simplifying. Hey, in the numerator, I got two fractions. It would be better if I had one fraction. So common denominator is 2ab. So change a 1 to 2ab over 2ab. So I'm going to add a 2ab to this numerator right here. I'm going to put it in the middle suspiciously. All I did was put the 2ab in the middle. Hey, I got a fraction over a fraction. I could. So I'm going to flip the 2 and turn it into 1/2. So what do I get on the bottom?
4
Yeah.
When it goes like simplify,
Well, slightly. Okay. So here's what I'm going to do. I'm going to put, well, I need a new sheet of paper, right? I'm going to take the start and the finish, put them on a new sheet of paper. Start, finish, new sheet of paper. If you didn't believe I made a mistake, start, finish, new sheet of paper. Okay, cool. All right. Evelyn says, let's do some simplifying up here. I'm going to put parentheses around the first, second, and third. Sorry. Yes? Hey, if I wrote this as, I don't know, x squared plus 2x plus 1, you would be able to factor it very easy, right? That's all it says. It says x squared plus 2x plus 1. Except it doesn't say that. It says a squared plus 2ab plus b squared. This is a perfect square, so all I got to do is factor the first, factor the second one, put squares root. That's what it turns into, right? If I ask you to do a plus b squared, it would turn back into that. Yeah? Okay. Now from out of nowhere, right? From out of nowhere, I'm going to tell you that this is a square by itself. For instance, if I wrote, go back one step, if I wrote that numerator as x squared minus 9, you would say that factor to, you would say this factors to,
Oh,
Plus or minus,
no.
say it,
plus or minus 3.
the whole thing, not just the plus or minus 3. So it would factor to x minus 3, x plus 3, yes? Well, that's because x squared is a perfect square and 9 is a perfect square. Well, that's a perfect square. Look, it's squared. A plus b is squared and c is squared. So that would turn into this first thing, a plus b, minus the second thing, c, times this first thing, a plus b, and change that minus to a plus. See what I did? A plus b minus c, a plus b plus c. It's the same thing as x minus 3, x plus 3. Okay? It's a hard proof. Well, if we multiply back, but we're not going to do that. We're going to use our old friend, u substitution. So this is the first of 5 magical things I will do. I'm going to use u substitution. Except I'm not going to use the letter u. They decided to use the letter s. They could have used u. They decided to use the letter s. They're going to let s stand for one of these. Except they put a half in front of it. Oh, you'll see why in a second. Okay, so they're going to say let the letter s. You can let s stand for any number you want, right? They let this stand for 1/2 times a plus b plus c. Well, I see the a plus b plus c, but there's no half here. So get rid of the half. Multiply both sides by 2 and you get that. So this says if I see an a plus b plus c, I can write 2s. Well, I see an a plus b plus c, so I can write it 2s. But this one doesn't say a plus b plus c. It says a plus b minus c. So here's their trick. They wanted to say a plus b plus c so they can do that substitution. So what do? Right? They make this equal minus c minus c. Right? What's c minus c? So this really still is a plus b minus c, except now I have 2 negative c's. So they write this as minus 2c. Well, this now stands for 2s. So this is now 2s minus 2c. And if I factor out a 2, I get that. All I'm doing is factoring out a 2 out of this. The a plus b plus c, we already know turns into 2s. So you get this, which came from here, factoring out a 2, and you get times 2s. Okay? All right. Yay. Now what? Okay. So their next step is, well, what's 2 times 2? I got a 4 on the bottom, so they would cancel. So now I'm left with that. Now I need a new sheet of paper. Okay? Not yet. Not yet. Right? Okay, so I got this right here. Yes? All right. So this is the second magic thing. So I went down the formula, right? And I got to this. You could do the same thing with sine. I don't have time to show it to you. So it's shown on this page, and that's the wrong number. It should be 550 something. But on that same thing where this section is, they do the same thing, except instead starting with cosine of the half angle, they do it with sine. It's the same logic, and they get to that idea right here. Okay, I'm not showing you it. It's just for sake of time. It's the same logic, though. Okay, cool. So now I am so far away from the start, I am nowhere near a formula. So I need to start bringing it back together. Okay, so what they do now is, well, they wanted to say cosine. So now they're going to go back to taking the square root. This should say plus or minus, but the answer is going to be, well, you're not going to get a negative in a triangle. So they already know the answer is positive. So I don't have to put a plus or minus because I know the answer is going to be positive. You can take the cosine of an angle, you're going to get a positive number. Same thing with sine, right? If you take the square root of both sides, you get that. Big hot mess, yes? Big hot mess. Cool? All right. What started this whole process, right, where we started, was this thing. We had this original formula. Because remember, this is the original formula for SAS, right? I said, remember this one, the SAS one? Here's your SAS formula, okay? All right, cool. Next bit of magic is this, right? they say, think about the double angle formula. The double angle formula for sine says this. And here's their logic, right? They say, if you double a half angle, you get back to the angle, right? So if I double a half angle, I get back to the angle. So they double a half angle. If you double a half angle, you get back to theta. So they can make this statement right here. All they're doing is taking the sine C and turning it into 2 sine theta cosine theta. But they doubled the angle, but when you double a half, you get back to the normal angle, which is what we wanted. So now we're at this step right here, and this says blah, 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 but then it says sine C over 2, cosine C over 2. That's convenient because look directly above, what's it say? Sine C over 2, cosine C over 2. So I'm going to take this formula right here and do this substitution right here. Oh, it gets messy. Right?
How long is this fruit?
Yeah? How did I know you were going to complain right then?
I have no idea.
All right. So I'm supposed to be making it easier and I'm making it more challenging. We're almost done. Okay. So we're at this step right here. Yes? I need a new sheet of paper. I'm right there. Hey, it's got a dot. How about we just multiply? Bottoms with bottoms, tops with tops. You multiply the bottoms, what do you get? A squared B squared, which is what's the square root of A squared B squared? AB.
Oh,
If I multiply AB times AB, I get A squared B squared. And if I take the square root of that, I get AB. The top is a big hot mess. I'm not even going to try to multiply them. The only thing I'm going to do is move this S to the front for a suspicious reason you'll see at the end. Right? So I get this AB that's in front. The bottom turns into AB. What do you immediately notice?
They can cancel.
Okay. And guess what you're left with?
A big mess.
You're actually left with the formula. Which, what did I say you're not going to do? What did I say you're not going to do?
Freaked out.
You're not going to freak out because, oh my God, look at that big ugly thing. I said once you do an example, you're going to say, oh, this isn't that bad. It sure looks bad though, doesn't it? Hey, do you know what A, B, and C are in this formula?
Sides.
Sides of this triangle. What's the obvious next question you need to ask yourself? What was S? It was the use
A
substitution.
plus B plus minus C.
It was literally that A, B, and C are the sides of the triangle, and the 4 versions of S were the use substitution. It's this, but look what it literally says to do.
Just add them all together.
Add the sides and. And so I said, don't freak out. You need both bits of information in order to make this work. This is the actual formula, but you also need this use substitution, although it's an S substitution, to make this work, right? So write all the, this proof was worthy of, you can fill in your own blank, right? Okay, so write this down. This is from a very smart mathematician called Heron. Some people call him Hero. Well, this is called Heron's formula. And so Heron's formula says if you got any triangle and you got the 3 sides, then this is how you calculate its area. Oh, and you also need to know what S is. S is the 3 sides added together divided by 2. No more proof. Everybody okay? We're out of the scary place.
You could have just given us the formula and we'd gone with it.
I know you would have, and that's what most math teachers do. They just say, take this formula, but you should always ask yourself, well, why is it true? I mean, you got to be able, we don't teach magic, we teach math. Until you get to geometry, we basically teach you magic. You trusted your teacher. Your 5th grade teacher never proved that 1/2 base time height is area of a triangle. We did in geometry, but your 5th grade teacher didn't show you that. Okay, priority of work for this. What should you do first? Find S. How do you find S? Add up all the sides and divide by 2. How hard is that? And you have a calculator. Once you find S, then there is a pattern here. It's S, then S minus A, then S minus B, and then S minus C. It's a nice pattern, right? S, then S minus A, then S minus B, then S minus C. But everybody forgets at the very end. Everybody forgets at the very end to root it, right? To square root it. So don't forget that. Okay, how many examples do you need?
Two,
Two? All right.
those are 20 on paper.
Well, yeah, but I'm asking you how many you need to do. Hey, do I need to draw a triangle?
No.
No, because it gave me the three sides. It doesn't matter the order. You can call, you want to call A, B, and B, C, and whatever. I mean, yes, I'd like you to use A for A, B for B, but remember, it's just three sides. What did I say the first thing you should probably do? Find S. How do we find S? 4 plus 5 is 9. 9 plus 7 is 16. Half of 16 is done. I found S. Right? Find S first. S is 8. What do you do with the 8? So start off with what button on your calculator? The square root button. So the square root of 8 times, and I would use parentheses exactly like it. I would not try to do it in your head or whatever. So 8 times 8 minus 4 times 8 minus 5 times 8 minus 7. 9.8. Wait for a couple other people. Evelyn's shaking her head. I got 4 root 6.
Maybe because you didn't put it in your calculator.
I got the exact answer. You guys got kind of close to the right answer. What does it say for homework? Exact or approximate?
It's give.
What page you-
Somewhere around 555, I assume. It's the last chapter, or last section of chapter 8, 8.4.
It says, find the area of each triangle, round, insertion. Do that.
Well, then there you go. They don't want 4 root 6. They want the 9.8. Okay. Do another one. Priscilla? No? Be still my heart.
Yes. Need help.
Okay. So Priscilla, what should you do first? No, I was actually proud that you said, I don't need another one. I got this. Let's do another one. Let's be totally confident. So what's the first step? So how do you find S? 37. And then take a half of that. Hey, be careful when you type that in your calculator. You want to know how you make an easy mistake? Well, think about this on your calculator. If you literally do 12 plus, everybody look at this, 35 plus 37 divided by 2, what's your calculator going to do?
Divide 37.
And it ain't going to divide 12 and 35 by 2. So if you want to do that, what do you got to do? Parentheses, or you could do the addition, hit enter, and then take the answer and divide by 2. Either one's fine, but make sure you don't type it in like this without the parentheses. Next, what's up next? So we got S. I got S as being 42. I'm sorry, sorry, not 42, but yeah, 42. Now what? Now plug it into this, square root button comes first. That's 42 times parentheses, 42 minus 12, close parentheses, times, open parentheses, 42 minus 35, close parentheses, times, open parentheses, 42 minus 37, close parentheses. That's a lot to say.
Not 210, and that doesn't seem right.
I got that too.
You could draw the triangle yourself and figure out if it makes sense. So let's see, I got a side length of 12, then I got a big side length of 35 and another big side length, something like that. So we're saying the area of this, if this is 35, and the height is not 12, but it's kind of 12. Well, half of 35 is around 18. 18 times 12 is what? I mean, that's just estimation. That's not the answer. But the fact that you got 210 and then I just estimated it as being 216, that to me sounds like I didn't make a mistake. Or I should say you didn't make a mistake. I didn't actually calculate. Yes?
Yes.
Okay.
Yeah.
What, you didn't look confident at all.
Oh, that's because I fat fingered it again.
Yeah, so how do you prevent yourself from fat fingering? You can't. But what you can do is at the very end, look at your, never hit clear. You look at your screen, Priscilla, and you should see this, right? Like make that be your last step after you get your answer. Like look at the screen. I mean, this also does require you to write all this out by hand, which is kind of a pain in the butt, right? But I'm saying force yourself to do it, and that way, that's the way you'll catch yourself from fat fingering your calculator. Because otherwise, you're not going to ever know. Calculator's going to say a number, like, oh, I think that's right. The other way you can do is just do it twice in a row. Just don't look at your screen. See if you get the right answer. All right, I did say there's one word problem. Ready? You want it to be an easy word problem or hard word problem? All right, this is the Seth word problem. Yeah. Why? You're the sports person.
Who doesn't play this though? Baseball?
Seth, did you know that the home plate of the baseball is called home plate because I don't know if that's the reason, but it sure does look like that way. All right. So according to our book, and I did ask Siri, and Siri did confirm this, these are the dimensions of the home plate for Major League Baseball. It's asked us, all right, what are your thoughts?
Make 3 triangles.
What's your thoughts? Okay, so Evelyn said, let's make, I can see that, right? I can make 3 triangles, but what's the
Those
problem?
are not my triangle.
No, I
Those
got
are ugly triangles.
Where's your 3?
Straight across and then horizontal.
So straight across like that,
Yeah, and then horizontal.
okay?
Yeah, my triangle.
And here's our 3 triangles. Could we calculate the area of the top triangle
Yes.
using her method?
Yes.
Well, we only have 2 of the sides.
You have 3.
What's the
Well,
third
why
one?
is it
17 inches.
Okay. Could we calculate the other 2 triangles? How?
Well. Those can.
It might be 12, but could we calculate this diagonal right here? Could we?
Probably
How?
some way to find C.
Look at the triangle itself.
Oh, wait, it's a right triangle.
Okay, so could we figure out that diagonal? So that would be one way. Top triangle, middle triangle, bottom triangle, but then we got to figure out this diagonal to get that third side. Is there another way?
Your ugly triangle?
Why is mine uglier than yours?
Mine's proportional and yours isn't.
What do I actually have? That's not a square stuff.
A rectangle.
If only we knew the formula for area of a rectangle.
Oh,
What's the area of a rectangle?
all of them multiplied together.
No,
Added together.
no.
That's, no.
How do you find the area of a rectangle?
Like times width times 9.
That's for a rectangular prism. Hey, why is this the one thing that's causing you a problem?
Length and base.
Because we don't use rectangles. The rectangles.
How many little squares did I just draw? Stop. How many little squares did I just draw? How many tick marks on the left side? 1, 2, 3, 4, 5. How many tick marks on the bottom? 1, 2, 3, 4, 5. How many squares are there?
5.
So what's the area of a rectangle?
Length times.
Times base.
That's not 5th grade, ladies and gentlemen. That's as soon as you learn multiplication table.
Side.
Now you made me depressed for the rest of the day that you didn't know the area of a rectangle.
So 8.5 times 17.
Okay, that's the rectangle. Now what?
And then
So how are we going to find the triangle?
our problem that we just did.
Yeah, Aaron's formula, right? So here's it nice and pretty so that Winter can see, right? So I have a triangle plus rectangle will be our formula. A rectangle is length times width, base times height, however you want to think about it. And the triangle, I got all 3 sides, then use the hero's formula. It's an SSS. S would be 12 plus 12 plus 17 divided by 2. It's going to be an ugly number this time. But luckily we have a calculator. I got 20.5. Hey, computer programming, right? Would this be something easy to write a program for? Area of a triangle?
Mhm.
Sure.
You would ask the person to input what first? You wrote a computer program, what would you do? What's the only thing you need for this formula? The three sides. So your computer program should first ask, what are the three sides? And then in the background, you would have Hero's formula. You would have S is equal to A plus B plus C divided by 2. And then plug that into the square root of S times S minus A times S minus B times S minus C. This would be an easy computer program to write. You might have, right?
1,000 times.
Right. Now, this requires you to know all three sides of a triangle. So this program would only work if you knew three sides. It really doesn't. $72 square inches. That's what I got too. But that's just the triangle. The rectangle. How big is the rectangle? So add that and you get. Now, according to Siri, that was the right answer. If you trust Siri. I do not trust Siri, no. But I did the math and I got the same answer, so. Does Siri trust me?
They don't like, they're scared of Google like spying on them and like taking their information, but they have like Instagram and Facebook. It's like,
Being a smart consumer of social media is important in today's age. Like I had this person yesterday ask me all of this information about me, and I readily gave it up to him. And then an hour later, I thought about it, I was like, why did I do that?
You have a sleepless night.
It didn't cause me a sleepless night, but I absolutely thought about it. I was like, I literally, if I didn't trust this person, I literally gave them information that you probably shouldn't give out, which is your birth date and your birth year and your birthplace. And I gave all three of those readily.
Why did you?
You should never, like, the only people that need that information are the people that like, hey, I'm getting a passport or driver's license or something like that. I'm applying for a job. They're going to pay me money for a salary and they need that information. But just some random person saying, what's your birthday? Where were you born?
Yeah, well, that's creepy. To go back to the SAS area formula. real quick.
Way back then?
Yeah,
What were you confused about?
like I always wanted to make sure I wrote it right.
Almost there. Almost there. Right there. That's it, Winter.
Did you tell your wife